The scientific method of discovery begins with a question or problem to be solved. And once you are thoroughly schooled on that problem, it's time to make a hypothesis. A hypothesis is a prediction that is often called an educated guess because your prediction must be based on some knowledge or observation. A good hypothesis will provide a strong framework for building your experiment. In our previous episode, we posed the question, what type of cup will keep hot chocolate warm the longest? And perhaps, after some in-depth research, you feel as though a styrofoam cup will insulate the hot chocolate most effectively. How can you put that hypothesis into words? To answer that question, let's start with something key to every experiment, something called a variable. A variable is something that can change. In this experiment, you are choosing to test the cooling rate of hot chocolate in different types of cups. The different types of cups, therefore, becomes your independent variable. The one thing you want to change throughout the experiment in order to determine which cup is most effective in insulating the hot chocolate's heat. Another key variable, called the dependent variable, is the effect you are trying to observe or measure in your investigation. You are trying to determine the extent to which the cooling rate of the hot chocolate depends on the type of cup it is in. In other words, if your independent variable is the type of cup, then your dependent variable is the cooling rate of the hot chocolate. To create your hypothesis, begin with the independent variable you think will be the best solution to your problem and predict its effect or relationship to your dependent variable. So if you think styrofoam will be the best insulator in keeping hot chocolate warm the longest, you might phrase your hypothesis something like this. If hot chocolate is in a styrofoam cup, then it will stay warm the longest in comparison to a paper or ceramic cup. Phrasing your hypothesis as an if-then statement shows that you expect the dependent variable, the temperature of the hot chocolate, to be affected by the independent variable, the type of cup it is in. Let's try another problem. How does colored lighting affect plant growth? Let's also say, after some more in-depth research, you think blue light might be the best for plant growth, while green light might be the worst. You think you may also want to compare plants grown under colored lights to plants grown under natural white light, which is what plants normally receive from the sun. So what do you think is the independent variable? The variable you are choosing to manipulate or change. The one thing you are going to change to see how it affects plant growth. If you said the color of light the plants will receive, then you are spot on. Your question, how does colored lighting affect plant growth, contains the independent variable, the one thing you plan to vary to see how it affects plant growth. What do you think the dependent variable is? In other words, what change are you trying to measure or observe when you expose plants to different colored lighting? If you are thinking the dependent variable is plant growth, then you've got it. By independently choosing to change the color of lights, you are observing the extent to which plant growth depends on each of these colors. After researching, you expected that blue light will have the greatest positive effect on plant growth, so you are now ready to declare a thoughtful hypothesis that reflects this well-educated guess. So just as you created a hypothesis about hot chocolate that stated, if hot chocolate is in a styrofoam cup, then it will stay warm the longest in comparison to a paper or ceramic cup. Try using this if-then pattern to create a hypothesis in support of blue light. I'll give you a moment to think. Did you come up with something like, if plants are exposed to blue lighting conditions, then they will grow better than plants grown under green or white lighting conditions? This if-then or cause and effect phrasing shows that you expect that your addition of blue light will cause the greatest growth in plants. Writing a good hypothesis that predicts the effect of one variable upon another will lead to the development of an experiment that does the same. Our next episode, you will learn to use this framework of the hypothesis to create an experiment that will provide evidence to help prove or possibly disprove your hypothesis. So stay tuned.
created using Powtoon.